You might remember that we have worked on this race car some time ago, and we have actually rebuilt the complete front part. Now we're going to rebuild the rear suspension and the drive shafts. And if you'd like to see on how we have rebuilt the brake calipers, how we powder coated the whiz bones, how we took care of all the bearings and the wheel hubs, then please check my YouTube channel. You'll find it all there on how that was done, and now we will need to do the same on the back side. And the rear end is going to take a little bit more effort than the front, especially since we have some damage which we didn't have in the front. So in the back we're going to remove all the whiz bones, so the lower whiz bone, the upper whiz bone, and all the joints and the bolts that hold the whole thing together. Also the adjustment rods, we have a couple of them. We have one for toe in, toe out, we got also one for camber. So all this needs to be checked, and of course we'll check as well the shock absorbers, which are a bit more inward, and you'll see those once we get to it. But there is another problem, and this is the drive shaft right here. And if you look carefully, you can see that somebody has welded this up. This is a modified drive shaft, so we have to get this sorted out. There's a wheel spacer on it that still looks pretty much intact, so we're going to keep that aside. Most likely the disc will now come off. The bearing feels alright, but I'm going to remove actually the drive shaft, so we'll need to undo this nut here. While I was rebuilding the rear brake calipers, and you can see that in my previous videos, I just got a new overhaul kit with new pistons, and this is the old piston that came out of one of the brake calipers from the back. Now the diameter of this one is 48 mil, and the one, to my surprise, that was fitted on the other side of the car was not 48, but it was actually 45 millimeters. So I couldn't even fit the piston inside. So this is 45. So somebody had fitted, you see, that doesn't go inside whatsoever. So somebody had fitted the wrong caliber on one side. As you can see, some people do really crazy things on cars, especially on a racetrack car. You don't want to mess around with these kind of things. You want to make sure that everything is correct, and that is why I'm taking this one completely apart. I'll check everything, and then we put it all back together, and we correct the things where we need to correct it, because at the end of the day, you're playing with your life. Now here we have the drive shaft, and you can see it's been welded up. So basically they made one up. So they got two good ends, and then they had to adjust the length. But you can see that one is not straight at all. I've placed a dial on the drive shaft, and you can actually see on the dial how badly this drive shaft is bent. You know, this is like 1.5 millimeter of play just on one rotation. So I'm not surprised, because the way they put this together by welding it all up like this, yeah, that's what you get if you don't do it right. And if you think that the shaft on the left hand side was bad, then have a look on the right hand side one. This is the one, and see how it's been welded up here. Really not good. And I'm not surprised the way it's been welded that it is not straight. But I'm just going to spin it around and you'll see it. See how that goes up and down. And it's quite a bit actually. Touch. So this is really an issue. So these shafts have to go out. They will have to be reworked in one way or another, or I have to get new ones built. We'll see how we're going to do it, but they have to go here. Yeah. Oh, this is a tough one. All right. That's two. There's in total 6 of them. That's it. Good. Good. And here should be the shaft, almost. There we go. So this is the drive shaft that we just got out of the car, and as you can tell, We've got two CV joints. This is one CV joint and that is one CV joint. And CV stands for continuous velocity. But these are not standard drive shafts. This is a combination of two different types. This side is actually coming from a Fiat X19, and I had to look it up on the internet to find out exactly where it could be coming from. Just looking first at the shape, but then counting the splines, the diameters, and all the dimensions. So this is for sure a Fiat X19. Now the other side is something else. And this side seems to be coming from a Volkswagen Golf. So they must have gotten both shafts for the Volkswagen Golf and the Fiat X19, and then they have cut the drive shaft in half and then welded those two pieces together to make a new one. So now we need to sort this out. Now before I can do anything on the shaft, I will have to disconnect it from both CV joints, and this is what we're going to do next. Now I have to say that I did order two new CV joints for each side of the car, and hopefully they are the correct types. I could just go with the dimensions on the websites, and if I have them, I'll put them up. If not, then we keep those because they are still good, and in the worst case, I'm having some spares. So this is going to be a pretty greasy job, so I might as well put my gloves on. Inside the CV joint here there is a circlip, and that's the one I'm going to try to move, and for that I'm going to use a circlip plier, and hopefully we can get it moving. What I see is that the top part is moving, but the bottom part doesn't open up. Alright, now let's try one more time. Alright, I got it. So now let's see if anything can come out. And hopefully it does. Oh man, this is really crappy inside, isn't it? So I'm going to have to disconnect the gator first. Should be fairly easy to disconnect. Here we go. And now I should be able to get it all off. Okay, let's get it out like this. So we have all these little balls that come out, see? There we go. Now it can come off. And there is another washer here that probably needs to come off as well. And I told you it was a greasy job, huh? And now you can see how greasy it was. So now I'm going to get the gator off. All right. So that is one side done. Let's clean it up a little bit. And I wasn't kidding when I said this is a greasy job. Now inside this cage here, you got these balls. I don't know if you can see it. The balls go right in there. I removed two because they were loose. So let me clean this up a bit because this is really dirty. Before we do anything else on this. Now you can actually see better these balls, they fit in this cage, and now I need to turn that back in. It's not always very easy to get it in, but all right. Need to fiddle with it a bit, but that CV joint seems to be in good condition, so I'm going to clean it completely up. I like to clean all the parts in a pot together so I don't mix them up. So now let's do this other side and see how we can get this fixed. I might want to do it like this. Try to pull it off like this. There we go. And now I should be able to pull back that gator. So we'll also need to cut this little tie wrap. All right. And now we can see this inner side here. I'll see a clip there. Yep, there is a clip. There's a clip right there. Not easy. So I have pulled off the gaiter, and inside we have a circlip. That's the one I need to open up, and then I should be able to pull things out. And this is where this little circlip is, and you had to push it open to get the shaft out of it. So that's the one. So here we have the shaft that we have to fix. Now the first thing I need to do is to measure the total length of the shaft, because I want to make sure that I retain that information just in case I have to get a new one made. So this looks like 377 millimeters, so I'm going to mark this down. And then I'm going to cut the shaft where the weld is, right here. And then we're going to turn on the lathe both pieces to the same thickness. So I already checked what the thinnest side is, and this was the one, which is 22 mil, and that is millimeters. I can't fit it here, so that's good. So I can take off a bit here, and I have to take off a whole bunch of metal right here. And then I'm going to put them back together, and we're going to weld them up, but in a V-shaped form, so they are exactly aligned. And if that doesn't work, then I just get a custom-made shaft for me, which is quite expensive, around 200 euros. All right, so we cut the shaft in two right on the spot where they welded it together. So now I can put it in the lathe and get it to the right size. I'm going to center that. Now, my lathe is not a professional lathe, but it's more than good enough for this kind of work. And that looks quite all right, so I don't need to adjust it. So on this part of the shaft, I grinded off already most of the welding, so I don't have to cut off too much on the lathe. And let's see if we can chuck that in properly. And the idea is that I'm now going to drill a center hole on this so that I can keep it very well into position while we're putting the lathe over it. This is the first part of the shaft which is ready. I did do a little cut on the top, so that's where I'm going to weld. But it's kind of strange how the material changes along the shaft. This is pretty shiny, but here we have kind of a weird spot. And you can actually see that they have used a grinder on it before. But overall, this is looking quite all right now. So now I will do the second part. So we turned both sides of the shaft on the lathe. I also made a concave part here on the top, because that's the area that I want to weld up. Now remember, because I've been cutting it with a disc, it got a little bit shorter, so now I have to have a space between the two parts when I'm going to connect them. So I'm drilling a little hole in the middle now, and I will put in a small pin so I can line up the two parts, and then we're going to weld up this whole area. And that should make it more than strong enough. I have machined both sides of the shaft to the same thickness. So now I can actually weld them together. I've been using two methods to weld broken drive shafts together. One method is using the lathe to center everything, and I'm going to show you that on how that can be done, but it is not how I'm going to weld it in this case. And the second method is using a V-shaped metal part where I can put the drive shaft in and making sure it's straight and then weld it up that way. That's what I'm going to do on my shaft right now, and there's a good reason for that. But let me show you what I mean with the adjustment and the centering methodology that you would normally use on a lathe if you wanted to use a lathe. Imagine that these two pieces are actually representing the two parts of the drive shaft. So on one side we're going to create a pin, as you can see here, and on the other side we're going to drill actually a center hole in it on the lathe. And once we have that, then we can put both pieces into the lathe, and I'll show you that in a second, because they will actually mate up and they will self-center. So you take one piece of your drive shaft and you put it in the claws of the lathe, and we just lock it into place. And as you can see, that's the piece where we created the pin on. And then the second part with the center hole, which is in this case exaggerated of course, and it's just for demonstration purposes, goes against it, and then you just lock it in place. Now remember, on this side you also have a center hole, and then you just lock that in place, and this is automatically centered, and all you need to do now is weld this up. I can't use the lathe really because I've been cutting them in two and I lost some metal. Of course I could have welded up the top of one and then machined it back down so I would have the right length again. Each of the shafts is having a concave edge, and that's because I want to fill that up while I'm welding it. And to keep the separation between the two, so I have the proper length, I created this little piece of cylinder that actually goes inside, and let's see if I can get it in, and that will hold the proper distance between the two. So let's see if we can get this on. See now, here it is. So you can see we still have a little gap there, and that's exactly the gap that I had while I was actually cutting it with my cutting disc. So if I weld this up like this, that should be all right. And I have ample of space to fill it all up from the core all the way to the outside. The method that I will use is based on a straight piece of metal, which we call a V shape. And I can place the axle inside like so, because they have the same thickness, it's cut all around, and now I have a perfect alignment. And all I need to do now is weld up this piece. Now I gotta watch out when I start welding that I don't get over the edges here, because then it will lift up of course, but this is a very easy way to do it. And this square angle piece of metal has to be of course straight, so you've got to make sure it's straight. And it has to be in a 90-degree angle all around the side, so it cannot vary. Huh? So that goes in like so, and of course both shafts have to be the same thickness. And now we will be able to do that, and you'll see that does not change at all. So let's start and see if we can weld it up. So now we're going to weld it up in the middle, all around, and then I'm going to see if it is straight, and then we weld it a bit more until we have filled up this complete gap. So that should be enough for now. I should be able to take it out and then see if it's straight or not. So with the shaft partially welded up, I'm placing it back in the lathe now, and now I'm just going to fill it all up. And it is quite straight, so that's good. So now it's time to fill all this up, and then we should have a good, proper shaft. So we installed a micrometer so we can see how much deflection the shaft has. If I turn it to the right, and then you'll see we get some deflection, but it's not that extreme. It varies a little bit, but let's say the worst case it's about 8. So every little demarcation on the scale is 0.01 millimeters. So the difference between the middle and the right hand side is in the worst case roughly about 0.08 mil. So this is 1/800th of a millimeter, so that's quite good. So let's try the other side. And the same thing happens here. You can see it's a little bit more, but not a lot. And it's about the same situation. So I am quite happy with the result on this shaft. So let's rotate the shaft. I set it to 0 and let's see how much deflection we have. It's about 300ths, 500ths. And in the other direction it's also about 4. So this is about, I would say, 0.1 mil difference. And that's not bad. And this is right on the spot where we welded it. Okay, so the shaft is now complete and I'm quite happy. It is straight enough for me. So the next thing we're going to do is to powder coat it. And I'm going to tape off the ends so I don't fill up the spines with powder. And I'm first of all going to degrease the shaft. And this is acetone. All right. I had to take some of the tape back off because I need to put the ground clamp up, and now I'm going to retape it. Let's see. The shaft is now in the oven. Let me close it and then we can actually start cooking. I've set the oven to about 181 degrees centigrade, and I'm just going to let it sit there for about 28 minutes or so, and we'll see. It's now warming up, and we'll come back in a few minutes. So time has elapsed, so let's see how it looks like, and I think that looks quite all right. And here is the finished drive shaft, and I think this is looking quite all right. I'm also going to install a new CV joint, but that's going to be for the next video. So folks, this is it for this video. We have fixed the drive shaft. Now that's looking almost as good as new. There's a little bit of play on it, not a lot. So now I'm going to continue to work on the suspension, but that will be on the next video. And I hope you enjoyed it as much as I did, and I'll see you in my next video. Bye-bye.